We're going to dive in and do a little bit of live coding then about these self-contained tokens and JWTs. So self-contained, I just mean like all the state associated with the token is encoded into the token itself rather than being in a database. They're sometimes also called like stateless tokens because there's no per client state on the server. So the book up until, so I should say, if you want to follow along at home, there's a GitHub repository here, github.com/Neil Madden/API security in action. It's also linked from the main page, I believe, somewhere, possibly in there. And this has all the code for all the chapters in the book. Now, if you check it out, the main master branch here has nothing in it at all apart from, you know, a license and a README. So all the code for individual chapters is in Git branches. So we're looking at chapter 6 here. So if you checked out the chapter 6, which is the starting point, so it's chapter 06, that's the starting point. That will give you the same code that I'm just using now. There's also a chapter 6 end. So for each chapter, there's an end branch as well, which is the finished code at the end of the chapter. So you can look, if you just want to look and see how the code ends up. Throughout the book, we kind of build up this kind of an API for a toy social network. It's really more of a kind of chat room API. It's a kind of RESTful API where you can create a user. You can then, when you've logged in as a user, you can create these social spaces, they're called. So they're kind of chat rooms. And then you can invite your friends to those social spaces, and then you can post messages and read messages. So there's a very simple kind of API. The API itself is everything's written in Java in the code, but I've tried to write it in a way that's kind of language agnostic. So it's not diving into some, you know, hugely powerful enterprise Java framework with all kinds of bells and whistles. I've tried to use a very minimal kind of set of tools so that the ideas are applicable to other languages as well. So that the framework I'm using to write the API is this thing called Spark Java, which is not related at all to the Apache Spark data analytics platform, by the way. But this is a very simple kind of framework for building APIs, which is based on things like the Symmetric framework in Ruby. And, you know, most languages have something similar now. So you kind of, you know, this is defining a HTTP GET request to /hello, and, you know, you get a request and response and return something. So it's all written with that. So hopefully, even if you're not that familiar with Java, you'll be able to follow along. And so at the point we get to at chapter 6, there's a reasonable amount, because each chapter builds on the next chapter. So there's a reasonable amount written here. So the main API is kind of written, and there's some basic security controls in place. And at the start of the chapter, all the tokens are being stored in this database token store. So there's this kind of token store abstraction, which I'm using in the book to then demonstrate different ways of kind of storing tokens on the back end. And that has create a token when you log in, read a token every time you call an API with a token, and then this revoke, which is kind of log out, which we'll ignore for this talk. And then the token itself just has a few details about the user. So it has a username, you know, who it is who logged in, the expiry time for the token, and then a bunch of attributes, which could be anything. So that could be, you know, how they were authenticated, what groups they're in, you know, if they're an admin or whatever. And so the database token store, we start off with just when you create a token, it just generates a random ID for that token and then inserts that into the database, into a database table with some attributes. And this is using SQL database, but you could use whatever, MongoDB or whatever you fancy. And then when it reads it, it just reads it out of the database and reconstructs that token object. So the idea with the self-contained tokens is that we're going to encode those directly into the token itself and not have a database. So we can kind of code like a really basic version of this, which is just going to encode it into JSON directly. We're not going to worry about security at this point. And then And then we'll kind of add it on like a basic version of a JWT framework first, so you can kind of see how a JWT works under the hood a little bit, and then we'll kind of switch to using a real JWT library to do the same thing. So first of all, let's just create our JSON object that's going to hold our details about the token, and we're just using a very basic JWT library here. So we've got the token username is going to go in there. We're going to use sub, so that's the subject of the token. So I'm going to use the standard names that are the JWT claim names. So part of the JSON Web Token spec is it defines a bunch of standard JSON fields which contain claims about a user, which you can use for these authentication tokens. And sub is the one for the username or some kind of user identifier. So it may not be a username that a user types in. It might be some kind of unique ID in a database or whatever. But it stands for subject, so it's the subject of the token. And then I'm going to put in the expiry time, which uses this exp format, and that's going to have the token expiry time. And in JWT, the value of that exp field is the expiry time in what's called epoch seconds. So that's the number of seconds since midnight on the 1st of January 1970. Which is this kind of, if you're not familiar with like Unix timestamps, that's the kind of arbitrary point in time which was defined as the epoch for Unix time. So that's how things are defined in JWT. So that's what we'll put in there. And then our token also has a bunch of other attributes, and we will just put those all together into another custom claim. So this is a non-standard thing, and we'll just dump them in there for now. So I'll talk a little bit about some of the other JWT claims that are standardly defined. What we will end up with is something that looks like, subject Alice, expiry time, which will be some number of seconds, and then some attributes, which, we might have role, admin, or something like that. Now, in fact, in this example, we're not going to have any attributes, so it will just be an empty thing. But that's what we're going to end up with. Now, this is not very suitable on its own for using as a token, because when we make API requests, like using curl or whatever, we're going to send this in an authorization header, and it would be kind of crazy to have all this kind of JSON syntax there. So all these kind of special characters are going to cause problems in that request. And so they're going to need escaping somehow, and that just kind of makes it more error prone for the client. So what we're going to do then is we're going to encode the JSON into Base64 encoding. So what's called URL safe Base64 encoding. So this is kind of a standard encoding. So Java's got a kind of built-in Base64 class that can do this. And basically all of the characters then that will come out in the string at the end are all fine to put in a URL or in a HTTP header without any kind of additional escaping or anything like that. So we will do that by taking the UTF-8 bytes of our JSON string, basically. UTF-8. There we go, and I'll import that so it's a bit shorter. So that's basically it. So we take our token, which has, our details about the username, expiry time, and the attributes. We code those into JSON, and then we encode that into this Base64 URL format. So what we'll get out at the end is some kind of string that looks a bit like that. It's just some randomish looking collection of bytes. Now, it's important that this Base64 encoding provides no security whatsoever. It looks a bit garbled, but it's not encrypted or encoded or anything. It's just an encoding, and it's very easy to reverse that encoding. So you shouldn't rely on that. We'll add some security in a minute. And then to read a token, so that's when the user logs in, they'll get one of these tokens back. And then when subsequent API calls are made, the client will pass that token in this authorization header, and then we'll end up calling into this method to decode it. And so the way we're going to do that is we're going to, first of all, we're going to remove that Base64 URL encoding. And then we're going to parse that as some JSON. So if we pass in the JSON bytes, and that was UTF-8, to get back in our original JSON. And then we can then unpack all the various fields. So we do also need to catch a exception here in case it's malformed. And here, the signature of this method returns an optional token. If you're not familiar with Java's optional class, it just allows you to either return a token or an empty value. So it's a bit better than a null, basically. So if there's an exception, I'll return empty, which signals authentication has failed, and the user will be prompted to authenticate, basically. But if there's no parsing error, then we can unpack all this. So we need to create our token. And the token wants the expiry time and the username, and the expiry time is an instant. So we will decode that. Get long. So we get the exp field, which was our epoch seconds, and we decode that into an instant, so Java instant object. And then we get the username, which is the sub claim. So we put in the expiry and the username. Then we have to unpack any additional attributes. And we can get that from the custom attributes claim we put in. It'll be a JSON object itself. If you remember, it was like, sub whatever. And then we had at the end attributes, and that was itself a JSON object with some stuff in it. It's a little bit clumsy doing this with the JSON library I'm using. In production, you might use something like Jackson or something like that, which has got more fancy JSON parsing library, which can do a lot of this kind of unpacking stuff for you. So we're going to loop through any of the attributes in this attribute, and we will set them in the attributes of the token. Right, and then we can return of token. So we parse the JSON, we extract the fields from it, reconstruct our token object, and then return that. And then the token controller in here, which is doing the login and validation of the token, will read the token and then check the expiry time and all that kind of stuff. That's developed earlier in the book. So if we now go into our main method and I comment out the database token store and put in this JSON token store and then kind of launch that, this all kind of starts up and is running the server on port 4567. And there's a bunch of stuff I can do now. So the first thing I'm going to do is create a user, because the way the API is set up at the moment, it creates an in-memory database, so it gets wiped every time you restart the server. That's just for testing. So I'm just going to create a test user with a highly secure password. Localhost 167 users. So that's how you create a user here. So you do a post to this endpoint. I have to include this header, so that's covered earlier in chapters. This is a kind of security reason for including that header. That's covered in chapter 2, I believe. And so it's created my user, and it's hashed the password and done all that good stuff. And so now I can log in as that user. So when I log in, I'm going to use HTTP basic authentication to the login endpoint, which is what this minus little u flag does to curl. So that will send an authorization header with the basic authentication scheme with this username and password in it. I have to supply this as well, just as a limitation of the API. I should say as well, there's a Postman collection for all of these API calls that is linked in the book, and it's probably too small to see on the screen, but there's a link here. I'll try and it's given in the book, so you can follow this Postman link and get a Postman collection which has all of the API calls. Well, I'm just doing it in curl here for the demo purposes, just to make it explicit exactly what is going on. So I have to do a post, so I have to provide that. And this is the session endpoint to log in. And what I get back then is this token, which is our encoded token. And in fact, I can just decode that on the command line here in the console. And you can see it is just our JSON. So we've got the subject test, an expiry time in seconds, and an empty set of attributes. So so that kind of basically works, and I can, go and now create a space. Just copy that token in there and do so there's a lot of typing here. I can call the endpoint to create a space. Let's call it Twitch space and pass in my username. And I'm going to authenticate with that token to the spaces endpoint API, and that's created that space. But this is completely insecure at the moment because this is just JSON and it's just Base64 encoded. So I can take this, I can change that JSON to say something like sub admin or something, assuming you've got a super user admin user. And then I can just change that subject to admin, re-encode that token, and suddenly now I've got a token that gives me access as the administrator user. So it's completely insecure to just use normal JSON like this. So how are we going to solve that problem? And the way we solve it is through something called a message authentication code. A message authentication code, or MAC, M-A-C, is a very fast kind of signature scheme. And what you do is you feed in some message into it. So in this case, our encoded token ID, and you feed in a secret key, which is some random key material, and you feed those both into this algorithm. In this case, we're going to use an algorithm called HMAC with SHA-256, which just stands for hashed based message authentication code, and that's the secure hash algorithm. And if you feed in the same message and the same key, you will get out a fixed length authentication tag. This is the code, and that is, for this algorithm, that's a 32 byte tag, and it's always 32 bytes. And for the same message and the same key, you'll always get the same output. But if even a single bit of this message is changed or if the key is changed, then you'll get a completely different output. And that's kind of a cryptographically secure algorithm. And what that means is that you can then attach this tag to the token or the message. So in this case, it's our token here that's been encoded. We attach this tag to it. And then when you read it in to the API, you can then do the same calculation with the same key over this part of the message and see if you get the same tag. And if you do, then it means it's a genuine token and it hasn't been tampered with. But if it's different, then it means somebody has tampered with the token, like changed their name to admin in here, or just tried to create a new token completely from scratch. And so you can reject those. And this is, HMAC is extremely fast, worst case sort of tens of microseconds, usually much faster than that. So you can do this check really, really quickly. It's very efficient in that way. And then you can just reject anything. It means that the only way you can get one of these tokens with a valid tag on it is by calling the login endpoint and getting one back. So this is what's called symmetric cryptography or secret key cryptography, because the same key is used to sign the token here as to verify it. There are also public key cryptography algorithms, which we'll maybe talk a little bit about later, where there are different keys. So you have a private key to sign and then a public key to verify. They're a lot more complex and there's a lot more that can go wrong with them. So in APIs, typically either the same API is producing the token that's then validating it later, or you have some kind of like centralized token service, which might be something like an OAuth 2 authorization server, which is generating those tokens, and then all your APIs are consuming them. But depending on your deployment and your kind of level of risk, it's often, those are all often within what we'd call a trust boundary. So they're maintained by the same people, they've got the same administrators, they're running on in the same network and stuff. And so oftentimes you can share this secret key between those elements. So there's some security advantages in moving to public key. So you can just have one service that has the private key, and all your APIs only have to have the public key, which is less of a problem if that gets stolen. But it comes with a lot of additional complexity, and there's far more ways that public key cryptography can go wrong than something like HMAC. So it's definitely something you want to think hard about before you move to it. I think a lot of people assume that public key cryptography is better and that they should use it.